So the last couple assignments dealt with finding the key features for specific graphs, quadratics mostly. This one says each problem represents a quadratic. Some key features, it's supposed to say are given. Determine the missing key features and sketch the graph. So there are a lot of things that you can describe in a quadratic. Some of them have been given, some of them have not been given. Can we take what we know and draw what we don't know? If you take a look at number 1, all of the items that we've described so far are there. Some of them are just blank. So you see domain, range, increasing, decreasing, positive, negative, max and min, zeros, y-intercept, and end behavior. The only thing we know about this graph would be, first, it's a quadratic. That helps a lot. We also know that its domain is all real numbers. Is that very useful? Every quadratic has domain all real numbers, so that doesn't really help. We know that it's decreasing from negative infinity to 1. We also know that it's positive from negative infinity to negative 1 and from 3 to infinity. We also know that it has a maximum or a minimum value at y equals negative 4, and the y-intercept is negative 3. Using that information, we need to fill in all the other information and graph the quadratic. Okay? So, given that information, what else can you tell me about that quadratic? Do we know what type of quadratic it is? Does it open up or does it open down? Is it a happy quadratic or is it a frowny quadratic? Opens up. Why? If you look at positive, there are... That's not working. So if you look at positive, there are 2 positive pieces, which means it has to open up. If it was a frowny quadratic, it would have 1 positive piece. If it's a happy quadratic, then it has 2 positive pieces. So at least we know what direction it opens up. All right, what else do we know? So does this have a maximum or does it have a minimum? How do you know it's a minimum? We know it opens up. So it opens up, which means it has a minimum, and we know that the minimum is at y equals negative 4. So I'm going to go down to y equals negative 4, and I'm going to draw a dotted line, and that dotted line tells me I can't go below there. Wherever the parabola is situated on this graph, the bottom of it is going to hit that dotted line. Does everybody understand? Okay? What else do we know? Okay, y-intercept at negative 3, so I can just go ahead and graph that. There's my y-intercept. Okay, what else? Ooh, what does that tell me? Decreasing from negative infinity to 1. What does this tell me about the graph? Yes. That's where it changes from down to up. So x equals 1 must be part of the minimum. Do you guys get that? So I have a parabola that looks like this, and it's going to be going down until it hits this point, and then it's going to start going up. Well, I now know the x value of that minimum. I also know the y value of the minimum. Where is the vertex? 1, negative 4. So this point right here is my vertex. Does anybody not understand how we did that? And all of these, each one of these problems is going to be different. You're going to be given different information, and you have to use that information to find everything else. So there's not one way to do this. You could have figured it out another way. But that is the minimum. Okay? What else do we know? What about positive and negative? Is that going to help at all? Does this tell me anything? Those are the zeros. The graph crosses the x-axis on those same points that are listed on the positive and negative numbers. So one of the zeros is -1, and one of the zeros is 3. And that's everything I need to draw the graph. Now I just need to fill in the rest of the information. Do I know what the range is? What is the range? So we look at the y values. Which y values show up? So if I draw a horizontal line, are there any y values that miss the graph? Yes, which ones? Everything below -4 misses the graph. So how do we describe, using interval notation, everything from here up? How do you describe everything from -4 up using interval notation? Y equals bracket -4 to infinity. Who understands that? Okay, so there's quite a bit of confusion, right? Is it figuring out which numbers to use, or is it interval notation that's the problem? Or both? Which one? What? So you get it's everything bigger than -4. So interval notation looks like this. It's either bracket, bracket, or parenthesis, bracket, or bracket, parenthesis, or parenthesis, parenthesis. Those are your 4 choices. Okay? Bracket means equal to. So like this bracket would be greater than or equal to. This bracket would be less than or equal to. This parenthesis would just be greater than, and this parenthesis would be less than. So if I put numbers in there, 4 to 5, that represents every number from 4 to 5, including 4 and including 5. Or if you're on the y-axis, it would be this way, 4 to 5, all of those. Okay? And you always put the small number first and the large number second. That's just the convention when you do intervals. So if I had this one, 4 to 5, that would be, if I did the same 4 to 5, it would be open circle, close circle. Because 4 is not part of the answer, but 5 is. And everything in between. Does that help, Megan? So this one, 4 to 5, would be closed circle on a 4 and open circle on a 5. And then the last one would be open and open. So everything in between 4 and 5, but not including 4 and 5 itself. Now, the only other thing you have to deal with is, what if you don't have an end on that other side? How do you describe everything from 6 up? Well, this is a closed circle, so it would be bracket 6. And then what's the right side going to be? Infinity. And you always put a parenthesis around infinity. There is no way to bracket infinity. You just can't get there. Okay, we'll get to that just a second. I want to do this other side. What if I did this? How would you describe that? Parenthesis negative infinity, that's the smallest number, to negative 3. Does that help? Anybody not get this? Okay, so going back to the graph, if we look at the range, the y values, every y value from here up exists. Y equals negative 10, there's no graph there. There's no point on the graph that's something comma negative 10 or whatever that is, 6, 7, whatever. There's no graph here, and there's no graph here. There's no graph here. The first time a y value shows up on the graph is at the minimum, which is negative 4. So this green line that this arrow I've drawn is everything from negative 4 up. So if I drew it over here, from negative 4 up to infinity. So we need to put that in interval notation. Negative 4 is the small number, so it goes first. And negative 4 is part of the graph, so it gets a bracket, comma, the top of the graph is infinity. Okay, and we'll be doing this a lot today. So we took care of the range. What about increasing? And the one thing you need to remember, all of the intervals are x values except for the range. And you're going to take the test, and some of you are going to put y values, and you're going to get it wrong. You always use x values except for the range. The range is the only y interval that we use. All of the others are x's. Yes? That's not an interval. That's just, yeah. All of the intervals are x values. But good point. The max or the min is a y value. Okay, increasing. Which x values create a graph that's going up? Well, do we know when the graph stops going down? It's going down from negative infinity to 1, and then from there on it's going to be going up. So the interval for increasing must be, get rid of all this stuff. What would the increasing interval be? 1 to infinity. Why did I put a parenthesis around 1 and not a bracket? At x equals 1, is the car facing up the hill or down the hill? And the answer is neither. It's at the bottom of the hill facing level. So you come down that parabola, you hit the vertex at the minimum, you're totally flat, and then you start driving up the hill. Okay? So we have the positive interval. What's the negative interval going to be? This piece here is negative. Which x's are represented by the bottom of that graph? Which x's create negative y values? Should be pretty easy. Where can I look to find those answers? The zeros. I could look at the graph, or I could look at the zeros. I could also look at this. It's positive from negative infinity to negative 1, and then positive again from 3 to infinity. So in between there, it must be negative. So negative would be negative 1 to 3. Parentheses or brackets? Why parentheses? On the x-axis, the zeros are on the x-axis, and they're not positive and they're not negative. So those are parentheses. Now if you notice, if you put the positive and the negative together, you get the whole number line. Also, if you put the increasing and the decreasing together, you get the whole number line. So if you know one, you should know the other without a graph. If you have one of those, the other one is really easy to figure out. Okay, do we know the zeros? What are the roots? Negative 1 and 3. And the last question, end behavior. As x approaches negative infinity, f of x approaches. So as x goes to the left, which direction is the graph headed? Up to infinity. As x approaches infinity, which is to the right, the graph is headed up to infinity. Okay, any questions about that? We'll do one more and then cut you loose. Number 2, domain. It doesn't give me a domain. Do I know what the domain is? How do I know it's all real numbers? Well, do I know what type of graph I'm looking at? They're all quadratics, and every quadratic has a domain being all real numbers. So we can go ahead and write all real numbers. Okay? In this case, all I'm told is the range, where the graph is positive, and what the y-intercept is. So I'm going to graph the y-intercept. I probably have to count by 2s. So 2, 4, 6, 8, 10, 12. Oh, wait. Sorry. Positive 12. So 2, 4, 6, 8, 10. That's my y-intercept. My range is negative infinity to 12.5. What does that tell me about the graph? It's a frowny face. How do you know it's a frowny face? The range says we go all the way to negative infinity, so it has to open down. So that's good. I know it looks like this. What else do I know by looking at the range? Go ahead. From 12.5 to negative infinity, what else does that tell me? It tells me the maximum. The graph never goes higher than 12.5. Which means that my max, I don't have a minimum, I have a maximum at 12, y equals 12.5. Now the only other piece of information they gave me was it's positive from negative 3 to 2. What does that tell me? The roots are negative 3 and 2. So negative 3 and 2. So I know it's going to look like this. Do I know where the graph is going to be negative? What are the intervals for negative? So this piece. Which x values create that piece? What's the smallest x for that left side? Negative infinity. What's the biggest x for that left side? Negative 3. And we need to union that with, what's the smallest x on the right side? 2. And the biggest x? Infinity. And again, if you notice, if you look at these 3 intervals, they take up the entire number line. Negative infinity to negative 3, negative 3 to 2, and 2 to infinity. Okay? We know that the roots, x equals negative 3 and 2. I know the end behavior. As x approaches negative infinity, f of x approaches negative infinity. And then the other one is x goes to infinity, which is the right side. F of x approaches negative infinity. The only thing I don't have would be increasing and decreasing. Do I know the x value for when the graph changes from up to down? It didn't give it to me. I need to figure it out. It's halfway in between the 2 roots. The minimum is, the x value for the minimum is halfway between the left root and the right root. So my left root is negative 3, and my right root is 2. What number is halfway in between? Well, on the y-axis. I counted by 2. You might have done it by 2s. It's fine. I counted the y-axis by 2s and the x-axis is 1. So what is halfway between negative 3 and 2? Negative 1/2. This is the halfway point. If I go straight up, the minimum will be right here, which is negative 1/2, 12.5. With that information, I can write down increasing. Which x values represent the graph going up? So that would be the left side. Which x values make the graph increase? What's the smallest x value on that left side? Negative infinity. And the biggest x on that left side? And it's really common here for you guys to say 12.5. Don't look at the y values, look at the x values. What is the x coordinate of the maximum? Negative 1/2. And if I know increasing, then decreasing is just everything else. So decreasing should be negative 1/2 to infinity. Okay, one hint on number 3. You have 2 choices for the y-intercept. It's either negative 3.3 or positive 3.3. You have to figure out which one using the information given. Okay? So you have a bunch of problems to do. I will put the answers up on the board. Good luck.